groups. On the periodic table, there are 18 groups. Some of them we need to know them by names. For example, group 1 is the alkali metal, Group 2 is the alkaline earth metal. Group 17 are the halogens. Group 18 are the noble gases. Group 3 to 12 are known as the transition metals. Group 1 is the alkali metals. They cannot exist as an element at STP, or standard temperature and pressure. They must be stored in oil. Therefore, they exist as a compound. They're very reactive. They have one valence electron. They're very soft metal and can be cut with a knife and have low density. Let's go back to this one valence electron. Let's take a look at group 1. You can see that in group 1, lithium has one valence electron, sodium has one, potassium has one, rubidium has one. So that means that all of the elements in group 1 have one valence electron. Group 2 are the alkaline earth metal. They're similar to group 1 except they're less reactive than group 1. They have two valence electrons. They tend to be harder than group 1 and have a higher melting and boiling point. So let's take a look at this two valence electron. As can be seen in group 2, the valence electrons are 2 for beryllium, 2 for magnesium, 2 for calcium, and so forth. So therefore, every element in group 2 have two valence electrons. Group 17s are the halogens. They have 7 valence electrons, very reactive. They form diatomic molecules. Remember, that means that the elements exist in pairs. They're poisonous. Fluorine and chlorine are gases. Bromine is a liquid at standard temperature and pressure, and iodine is a solid or it can be a vapor. Group 18s are your noble gases. They have 8 valence electrons. That means they have a complete outer shell. Therefore, they do not tend to react. They are gases that exist as individual atoms. That means they are not diatomic. And because they have 8 valence electrons, they tend to have a stable electron configuration. So elements in the same group, group 1, 2, and 13 to 18, have the same number of valence electrons. Helium is the exception for group 18. It only has 2. And therefore, all of the elements in the same group will have similar chemical property. Now, we mentioned that the reactivity for group 1, group 2, and group 17 tend to be fairly reactive, with group 18 not being very reactive, not reactive at all. In reactivity, we can see that as metal atoms get bigger, atomic radius getting bigger, the valence electrons are further from the nucleus. Thus, they are more easily lost. So, therefore, they are more reactive. Similarly, as the non-metal atoms get bigger, the valence electrons are further away from the nucleus also. Thus, less likely for the atom to want to gain more electrons, thus less reactive. So let's take a look at an example in which we have two metals, beryllium and sodium. Now, beryllium has 2 electron shells, and the valence electrons are located in the second shell, while sodium has 3 electron shell and the valence electron is located in the third shell. So beryllium valence electrons are located closer to the nucleus than the sodium valence electron. So as a result, as the atom get bigger, in this case sodium is bigger than beryllium, then the valence electrons are further and further away from the nucleus. Therefore, it is a lot easier to lose this valence electron from the third shell than it is to lose the 2 valence electrons from beryllium. As a result, sodium is more reactive than beryllium. In regard to the nonmetal, fluorine and chlorine will be our example. Now, fluorine has two shells, and the valence electrons are located in the second shell, while chlorine valence electrons are located in the third shell. So therefore, chlorine valence electrons are further away from the nucleus than fluorine's are. And as a result, chlorine will have less tendency to want to attract another electron to complete the attack than fluorine will. So as the atomic radius get bigger, the elements will become less reactive because they will have less tendency to want to gain electron.